Good evening. Welcome to the fourth broadcast of the 2025 National Astronomy Week. I am David Arditi. I am the Vice President of the British Astronomical Association. National Astronomy Week is a collaboration between various astronomical organisations, the British Astronomical Association, Society for Popular Astronomy, Royal Astronomical Society, and local societies up and down the country. And for this broadcast this evening, as in the other broadcasts at 7 p.m. all this week, we've got a selection of observers with telescopes up and down the country, and also some in other parts of Europe, to hopefully be able to show you what's going on in the sky. The theme of this National Astronomy Week is the planets on the ecliptic. We've got an amazing display of planets at the moment. We have all the planets, all the naked eye planets are visible apart from Venus in the evening sky. Now, the press has made a certain amount of this, talking about a great alignment of planets. Are the planets aligned? Well, it depends what you mean. The planets are always aligned. They've been aligned since the solar system was formed 4 or 5 billion years ago, and they will be aligned until it ends in a few more billion years, probably destroyed by changes in the sun or collision with the Andromeda galaxy or something. So the planets are always in a line in the sky because they orbit the sun in roughly the same plane. They were formed out of a rotating cloud of dust and gas, which formed into a plane. And so the orbits of the planets form a plane. And we can see this if we look at a chart of the night sky tonight, which I will show you now. Chart of the night sky. And there we see from the western horizon, we've got Neptune very low down. Next up, we've got Venus, then the moon tonight, then Uranus, then Jupiter, and finally Mars. And Neptune is Neptune is almost setting as well. And you'll see the planets are very close to this line, the ecliptic. And the ecliptic is the projection of the plane of the Earth's orbit into the sky. And the constellations surrounding the ecliptic are the famous 12 zodiacal constellations through which all the planets move. The planets are not exactly on the ecliptic, and you'll see that Mars is considerably above the ecliptic at the moment, and the moon is a bit above, a bit north of the ecliptic, and that's because some of the planets have orbits that are a bit inclined to the orbit of the Earth, and therefore at certain points in their orbit they can get somewhat away from the ecliptic, and that's the case with the moon at the moment. The moon is, in the next few days, more or less at the furthest north in the sky that it can ever be, and the same is true of Mars, and Venus is also somewhat north of the ecliptic. But basically the planets are in this line, but it's not an alignment. They're not aligned in space. Venus is right over there in the west, and Mars is right over there in the east. So they're on opposite sides of the sky, and Jupiter's in between. So there's no alignment. There's nothing special happening here. And this is quite common, that we can get all the planets in the evening sky. But it's a lovely thing to see. And that's why we're celebrating it this National Astronomy Week by following the moon from night to night as it hops from one planet to another. And tonight it's between Venus and Uranus. But we haven't in this series of broadcasts shown Saturn at all. So I'll stop showing you that chart. And I have a note here that we might be able to view Saturn, although it's very low from the UK. It's a bit higher from Spain, and Grant Bowskill operates a remote telescope in Spain, and he thought he might be able to get Saturn from there. So, Grant, are you able to see Saturn still at all?
Absolutely, yeah. It's very it's quite small on the screen, and it's a little bit wibbly wobbly because of the seeing conditions and how low it is. You can also see the colors a little bit distorted because of how low it is in the sky. But you can definitely see some rings. Hopefully that's coming through
Yes,
okay.
you can see the rings just about, yes.
Yeah, I mean
Uh,
they're very edge on at the moment, so they're quite difficult to discern compared to other times when they're very flat towards us. So that's always a bit of a challenge.
Indeed, they'll be actually edge on next year, and they will then become very difficult to see in small telescopes, but big telescopes will always pick them up. So what telescope are you using and how are you operating it?
So this is a 10-inch classical Cassegrain telescope over in Spain. It's actually equipped with multiple cameras on the back. We use it for different purposes, and because the seeing isn't great, this camera's a little bit more forgiving than some of the others, so it's a reasonably high pixel size. And I'm operating it over the internet using remote desktop software, just like a lot of people would use in their own back gardens. But this happens to be in southern Spain, in Granada, and is a telescope we use to do outreach and some imaging as well.
So what do you do mostly with that telescope?
Well, to be honest, my the planetary side of it is a secondary. The main reason I use it is for deep sky imaging, and it has a piggyback smaller telescope on top, which I use for wide field deep sky imaging predominantly. But it is nice to be able to do some planetary and lunar as well when it's cloudy in the UK. It does a much better job of lunar, I have to say, than the planets. I think capturing the planets is always tricky to do remotely because getting the focus just right is really challenging, particularly when the seeing is wobbling, as you can see on the screen all over the place.
It is, and the targeting is quite difficult. If you've got a narrow field of view, you need a very accurate drive and go-to system to be able to find them at all. So you've done very well there in getting Saturn bang in the middle of the field.
We try, yeah. It's a very good point actually, because the go-to on this does need remodeling, so it does take a little bit longer to get centered. But you're absolutely right; it can be very tricky to get the planets centered.
I mean, my go-to isn't as accurate as that here at my observatory in northwest London. I use a method of having a flip mirror where I can divert the light to an eyepiece and actually look through the eyepiece to put the planet on the center in the center of the eyepiece, and then the mirror can be flipped so that then I know the planet is definitely going to end up on the camera chip. But obviously, you can't do that operating remotely.
No, no, absolutely. And for beginners, I mean, having your finder scope accurately aligned will really help you find your planets, especially if you're trying to find them visually. And start with a nice low magnification eyepiece as well. Otherwise, you'll be hunting forever trying to find the tiny little planets.
Mm. Well, for people who've never seen Saturn, this isn't a very good introduction to Saturn because we can hardly see it at all. It's so low down. And when Saturn is at a decent altitude in the sky, as it will be by about April, no, later, no, much later, no, in the summer, it will be in the summer and towards the autumn of 2025. It'll be a decent altitude in the night sky. Then will be the time to train telescopes on it. And then you should get some lovely views of Saturn. And it's always lovely to see Saturn with its rings and with its moons, with major moon Titan and other moons that you can see with small telescopes. So thanks very much for that, Grant. And we will carry on through the planets because we might be able to look at Venus, which is we'll miss out Neptune as that's too low now. But we have an observatory operating in Bristol, Bristol Astronomical Society. Are you there, Bristol Astronomical Society?
Hi, David. Yes, we are.
And are you able to show us Venus?
Yes, if I can share my screen, I shall do that. Um, so I hope you can see that.
Yeah,
It's a wobbly Venus. It's getting lower and lower as we were speaking. But I hope you can see that it's a distinct
yeah,
crescent shape.
that's
Although,
very nice. Again, there's a lot of false color in the image. That's simply due to what we call dispersion in the Earth's atmosphere. The Earth's atmosphere refracts the different colors away from the horizon to different extents, and that's why we get also phenomena like the green flash when the sun sets, when the colors all become separated out when it's so low. But Venus is about 10 degrees up, I should think now. So that's good that you're able to get it at all. You must have a good horizon there.
Yes, we're blessed with a good horizon just south of Bristol here, so we can see all around the meridian really. So it's very good.
And what
And
telescope do you use?
I was just going to say tonight, Venus is what they call 36%. So its phase is 36% of the surface visible tonight. So that's why it's a crescent.
And what telescope are we looking through here?
So we're looking through a Meade LX600 with a Starlock system. So it's got two other smaller telescopes locking onto the target, and it works surprisingly well.
So that's the Schmidt-Cassegrain telescope, is it?
Yes, yes.
Yeah. So it's a telescope that uses both mirrors and glass surfaces. What's the diameter of the objective?
12 inches.
Right. So it's quite a big telescope.
Yeah, it's not bad. It's one of our main telescopes we use here at the observatory.
And do you have other telescopes at the observatory?
Yes, we got this telescope called an NGT, which is 18-inch. It's quite an unusual telescope, and we're in the process of refurbishing it at the moment. And we've just been gifted a small 80mm refractor imaging system complete. So we're quite keen to get that going up, get it going in the very near future.
Well, that should be useful because your 10-inch Schmidt-Cassegrain is a very long focal length telescope, good for the planets. So it'd be good to have a short refractor to get the wide field views as well. And I think Venus has just set as we were speaking.
It probably has, yes. I was just going to show this one slide just to show the phases of Venus, if I may, just quickly.
Carry on.
So this is just showing that the Venus changes in appearance as we get closer to it, as we move around our orbit and Venus inside. So it goes, well, this is just illustrating it going from about half, 57%. Tonight, it's about here, 36%. And then it gets thinner and thinner, but bigger, and ends up with a very, very fine crescent later on in the year. Well, later on next month, I think.
Yeah, this will all be happening over the next month, and Venus will get so big you'll be able to see the crescent phase in binoculars. You can't see much in the way of surface features on Venus, even with a telescope, because we look at the top of a very thick atmosphere. You can occasionally see subtle, vague markings, but as Venus is shrinking to a crescent phase, that becomes more and more difficult. But it's fantastically bright in the evening sky. So in case you don't realize, Venus is the evening star. That's that fantastically bright object after the sun has set. It can even be seen if you know exactly where to look before sunset. It's so bright. You have to be able to focus your eye on the right spot, a correct spot. So well, that's good that we've managed to get Venus there. And going round the ecliptic, we're going eastwards now, and the next object going eastwards is actually the moon. And Dave Eagle, who is in the English Midlands, has a little telescope. It's a smart telescope, very modern telescope, which is intelligent. It's called, supposedly, it's called the Sea Star. And Dave Eagle said he was going to point his Sea Star at the moon. So how are you doing with that, Dave?
Yeah, we're all good on that one. So here we go. So I'm going to share the screen now. So you should now be able to see the moon.
Yes, there it is.
And so it's nearly what we call first quarter, shows a half phase. And this is a view very similar to the view you'll get in binoculars. Because you see those dark and the brighter areas. Now, the darker areas are much flatter. So this is where lava over the years has flooded into these impact areas. And then the brighter areas are where there's more impact. So they're a lot rougher. Because we know that the vast majority of the craters formed on the moon have been created by impacts over millions of years. And you see those nice dark patches there, and some people at full moon say it looks like a face or a rabbit or a lady carrying sticks or whatever. There's lots of mythology surrounding that. And if we zoom into the moon, now it's a slightly different angle because, well, I've rotated the view of the phone on the screen. So it's a slightly different angle to how you'd see it in the sky at the moment. But if we zoom in, you'll see the problem that we have when we start to magnify things, because although it looks really clear and crisp at the moment, if we start to zoom in on the image, we get a closer look at those craters. But you start to see how it's all jiggling around, and that's caused by our atmosphere. So that's disturbing the light as it comes in. And that's what was causing the problems with Venus and Saturn we were looking at a little while ago. Now, the moon's a bit higher in the sky, so it's not affected quite as much as the planets. And we're not using quite as high a magnification either. But if you zoom in, you can see some of those craters there. And that one you can see almost in the middle there with it's like a mountain right in the center. I'll try and get it in the center. Yeah, that's called Maurolycus. You see that little like a dimple in the center? That's a huge mountain that's been thrown up by the impact. It's rebounded and causes a crater with a central peak in there. We come down to the bottom. So this is the southern part of the moon. You can see just how heavily cratered that is. If we go back up, you can see some more of these craters.
So you've got Theophilus, Cyrillus, and Caterina, that famous chain of
In
craters.
the middle here, yeah, and you've got that other feature just below it, which is like a wall. You can see a and then if we come up, we come to, so right in the center now, we've got Mare Tranquillitatis, which is where the Apollo 11 astronauts landed. And you can see there's a slight difference in color between the Mare to the left and Mare Tranquillitatis.
Yeah, that is actually quite striking.
It's actually showing quite nicely here. On the left-hand side, you can see that Mare, or sea, because they used to think these were oceans, so they've all named after seas and oceans. And that one has got a lot more iron in the surface, so it's a lot browner than the Mare Tranquillitatis, and that is a bit bluer in color because there's a lot more titanium in the regolith, and that's the name we give to the soil on the surface of the moon, because it's not soil as we know it, it's just dust that's settled on the surface. And if we go right to the top, you can see some more of these other craters here.
That brightest crater you've got in the top right, that's Kepler, which is a ray crater, and you can see some of the rays spreading out from it and then crossing the Mare Crisium. The ray craters are thought to be some of the most modern impacts, and they've spread out this ejecta, these rays of ejecta, which have not been disturbed by any later events on the moon. And some of the ray craters are only probably of the order of 100 million years old, and Kepler looks like one of the youngest craters on the moon.
Yeah, that the circular area you can see just next to Kepler there, that's Mare Crisium, or the Sea of Crises, and that's I'm not sure how wide that is actually, but a bit of wind blowing the sea star about there. And then we come up to the northern part of the moon. But if we try and zoom in on this, you see it looks a lot blurrier. You can see that disturbance from the atmosphere. But of course, to get good resolution of the moon or the planets, we need a bigger telescope.
So that's very nice that you can do that with the sea star, and that's done through software, isn't it?
That's just using, so you can see the interface I'm using there is just a smartphone, and I'm just pinching and squeezing the screen to zoom in on the image.
So that's radically different from traditional telescope observation.
It certainly is, yeah.
Change the scale, you would have had to remove your eyepiece, find an eyepiece with a different focal length and put it in to change the magnification, and then you would have had to refocus.
Yeah.
This is really a different thing altogether.
It's completely different, yeah.
And it's a tiny telescope with only 2-inch aperture. But you can do an awful lot with it, as we've seen, and you can also detect some very faint objects.
Yeah, and you can. And what I'm going to do now, I'm going to attempt, this is always dangerous, isn't it? I'm going to attempt to make it a lot brighter. So what we're going to see, we're going to increase the exposure. We're going to make it a lot brighter, and hopefully we're going to see the dark side of the moon, or the nighttime side of the moon, we should say. So you can see we've overexposed the moon. Oh, it's starting to drift away from me. That's all right. It's going. Oh, no, it's not. Yeah, it is. Come on. It's going to recenter itself in a minute.
So it recenters itself. It just
Yeah, it's recentered the moon.
it does all
Right.
it does all that by itself.
There we go. So I was going to intercept then, but it was managing to do it okay. So what I've done now, I've increased the brightness so you can see the sunlit side is now too bright, it's overexposed, but you can now see the nighttime side of the moon that's in darkness. And the light that's falling on it to make it illuminate is reflected back from the Earth, because the Earth's covered in clouds as well, and the sunlight reflects off the Earth onto the moon surface. So we see that faint side still when we increase the exposure.
Yeah, we can just about see the features on
You
the.
can just, let's see if I can get it a little bit brighter. Yeah, you can see some of the features there. You can just about
Yeah.
You can just about see some of the features. And if we expose it even more, we may even get to, oh no, so I think that's as bright as it's going to get.
Well, anyway, we'll see.
Sometimes you can see background stars, it's passing close by as well. And occasionally a star or even a planet can go behind the moon.
Yeah.
It moves across the sky.
And that's known as an occultation. And later in the week, we've got, well, something close to an occultation. We've got Mars being occulted by the moon, but it depends where you are, whether you can see it. Will be on Sunday, the last day of National Astronomy Week, and Mars will be occulted from the moon as seen from the north of Scotland, but not from England.
And it looks like the clouds are coming in.
Yes, right. Well, let's take that as a cue to leave Dave. Because I asked for Grant, who we've already seen Grant's telescope. We've seen results from Grant's telescope in Spain when he was looking at Saturn. And I asked if Grant could put the 10-inch telescope in Spain on the moon. Have you managed to do that, Grant?
Yeah, absolutely. Here we go.
And so let's see what it looks like through a telescope 5 times the size of the one we were just using. And this is what it looks like. And that pair of craters, is that Aristotle and Eudoxus? I think possibly. It's right on the terminator.
What we can do is we can just have a little explore. I mean, you can see the effects of the seeing conditions over there. It's still quite wobbly. And I've brightened it up to just make it a bit easier to see on the screen. But you can hopefully clearly see the extra resolution the larger telescope gives you. You can see a lot more detail on the surface. You can see smaller craters. And if we image this, if we took a stack of this, I'm sure we could really sharpen this up quite nicely and freeze the seeing effects that we're now seeing.
Indeed, and that's how amateur astronomers these days take pictures of the solar system objects, by taking many short exposures and then using software which can sort them out and choose some of the sharper ones to combine into a final sharpened image. And doing that, we can actually get to even more detail than we would be able to see using the eye looking through the telescope. But that's yes, we're seeing a lot of detail there. I should think the smallest craters we're seeing there are about 1 kilometer in diameter, and those big craters are between 50 and 70 kilometers in diameter. And you see many of the mountains on the moon. You see the broad flat plains typically are surrounded by mountains because they're the same thing as craters. They're impact basins, but huge impact basins, and they threw up the impactor threw up mountains when it created a great explosion when it impacted the moon. And there are several of these big roundish impact basins on the near side of the moon, such as the Mare Serenitatis, the Mare Tranquillitatis, and the most famous one, the Mare Imbrium, which is not really revealed to us at the moment, but will be revealed in the next few days as the phase of the moon increases.
Because there's some of the brighter areas and the carry on going downwards.
And you also note how much brighter the moon is away from the terminator. So you need a camera with a large dynamic range, or you need to keep altering the dynamics of the camera, the dynamic response of the camera, as Grant has now done, in order to successfully see the more brightly illuminated areas away from the terminator, whereas the human eye absorbs all that difference quite easily. And when we look visually, we don't really notice it.
I mean, I was going to say this is where I find the moon absolutely fascinating, because every night that terminator is in a slightly different place. The craters all look slightly different. The shadows all look slightly different. And I think when you start looking at it through a telescope, either with a camera or visually, you just see so much that you have no idea. When you look up at the moon, you have no idea how much is going on there and how many craters there are, and the layering of the craters as well. I always find quite fascinating to see, what crater came first. And looking at the shadows as well, I always find it very interesting. I mean, I don't know if you can see my cursor on the screen, but the crater at top right with the sort of brightish left-hand side and dark right-hand side,
So we do see that.
shadow gives you that kind of idea of what the shape of that rim of that crater must be like by the shadow. And I always find that really, really fascinating.
And when they're in shadow like this, you get an exaggerated impression of the depth of craters. They're not really all that deep. They're like shallow bowls. They're never much more than a kilometer deep, although they can be over 100 kilometers in diameter. So they're shallow depressions. And yes, it's always different. Although nothing changes on the moon, the view is always different because we get a slightly different view of the near side of the moon. We get a cycle of different librations, and we get different phases all the time. So it repeats on a cycle of 18 years, the Saros cycle. But in practice, it's always different every time you look, and that's the fascination of the moon.
Going down.
Right, thank you, Grant.
Pleasure.
We've seen quite a bit of the moon today, and we will see more in subsequent evenings. But let's carry on our tour of the ecliptic, going eastwards from the moon. We've got, between the moon and the brilliant planet Jupiter, we've got the much fainter planet Uranus. And I actually took an image of Uranus last night. Uranus is magnitude 6. It is on the limit of naked eye visibility. You won't see Uranus from a light polluted town environment, but binoculars will pick it up, or a small telescope. And so what does it look like through a telescope? It looks like this. That is Uranus as imaged through my 14-inch telescope last night. And this is actually a video. So does the video play? It's video taken at 1 frame a second. Yeah, so it's 1 frame a second. So when we were looking at the moon just now, we were probably seeing about 50 frames a second. So it was all smoothed out. But because Uranus is a lot fainter, have to expose it for a lot longer. And it's also a fairly antiquated camera as well. You could do better than 1 exposure a second with a newer camera. But even with a big telescope, even with a 14-inch telescope, I had to take exposures as slow as 1 a second. And so the seeing is making it a bit blurry. I think you can get an impression that it is a tiny disk. It's a tiny ball out there, something like 2 billion kilometers away from the Earth. It is fairly featureless. It's a gas giant. Well, it's an icy giant, and it probably contains some rock as well. We don't really know all that much about Uranus. It has been visited by one probe, by Voyager 2, but that was back in the 1980s. And we desperately need to send a new mission to Uranus and its twin outer planet, Neptune, because we know so little about them. It's disputed whether it's mostly consists of ices or maybe it's a mixture of rock and ice. But there's a lot of ice generally out in that outer part of the solar system beyond the orbit of Saturn. So there'll be a lot of water ice and a lot of frozen methane. Through amateur telescopes, we can't really see anything on Uranus. It's too small and it has very low contrast features. But there does seem to be a slight color difference between the two sides in this image. That I haven't really established whether that's real or not. But Uranus lies on its side, as it were. Its axis, its rotation is more or less horizontal as we view it here. And we do find that one hemisphere is a slightly different color to the other hemisphere. And because it's lying on its side, as it were, it's the left-hand side is a different color to the right-hand side. And particularly if we take an image in a non-visual wavelength in infrared light, this is an image in white light, so it's showing the true greenish color of Uranus. If we take an image in infrared light, then we tend to see more contrast. Occasionally we see spots on Uranus through amateur telescope, but that's quite rare and it does require large telescopes. So generally with a small telescope, when you look at Uranus, you'll see a little greenish, tiny greenish disk, and you have to magnify it quite a lot. You have to magnify it about 200 times maybe with a telescope of 3 inches aperture or more to see Venus looking something like this. And it moves from night to night like all the planets do, so we can identify it as a planet, as William Herschel did back in the late 18th century when he discovered it from his home in Bath. And at that time, William Herschel was an amateur astronomer, and he was actually a musician, and astronomy was his part-time passion, his hobby, but he became world famous through discovering a planet and then became a professional astronomer in the pay of King George and was able to move to Slough to be near the king and given money by the king to construct huge telescopes. And then he studied lots of other things in the sky apart from planets. He studied the deep sky objects, as what we would call today the deep sky objects. He studied the nebulae and clusters, and he made a big catalogue of them. And later tonight, Trevor Pitt will be telling us about his visual observation of the deep sky objects that were discovered by Herschel, the Herschel catalogue of objects. But this is Uranus, and it's in the sky. It's well placed at the moment, well placed near Jupiter. And we haven't looked at Uranus so far in this National Astronomy Week, so I thought we'd try and complete the set by having it tonight. So that was taken last night from my telescope, which is completely cloudy here in northwest London tonight. But luckily, in more westerly parts of the country, it is not cloudy. And the next planet round, Jupiter, we have, and indeed it's clear luckily it's also clear and not only in certain parts of England is it clear, but it is clear in Spain still, and Grant has been able to point his 10-inch telescope in Spain. It's very lucky we've got contact with that telescope at Jupiter. So Grant, would you be able to show us Jupiter?
Of course, here we go. So we've got a nice, yeah, not too large a scale, and the scene's not great, so I don't want to push it too hard, but hopefully you can see some reasonable detail coming through there. And if I boost up the exposure, there's some moons as well, and I cannot tell you what they are, but I'm sure somebody will be able to tell us.
No, I haven't looked up which is which, but it will be one of Europa, Ganymede, Io, and Callisto.
Again, you're going back to, if you were looking at this visually, you would be able to see the moons and the planet surface with your human eye can do a better job of that than the camera. With the camera, you have to boost the exposure to pick up the moons because they are significantly fainter than the planet. See if we can make it a little bit bigger.
So is that the red spot there? We got the red spot.
Yeah.
I think we can just about, it looks a bit pinkish rather than red, but on the upper right hand belt, which is the South Equatorial Belt, there is a pinkish patch, which is the Great Red Spot, which is not looking that great this year. It's shrunk a lot in the last few years, and it may be dying out. We've been observing the Great Red Spot with our telescopes since about 1870. And if you consult drawings made in the 19th century, and even photographs were starting to be taken then, at that time, the Great Red Spot was really big. It was covering about 20 degrees of longitude. And since then, it's been steadily shrinking, and it's a storm, and it's a whirling storm, and it's shrinking and it's accelerating. And we can measure that in with amateur images, amateur observations taken with big amateur telescopes, where you can actually see the rotation of the Great Red Spot, and we can measure it. And it's also been measured by space probes, and it's speeding up. As it's contracting, it's speeding up. And another interesting fact is that a red spot was observed by the Dutch astronomer Huygens in the 17th century. And some books say that that was the Great Red Spot, but I don't think it was. I think the red spot that we see today formed in the late 19th century. It formed when it was first observed in the 1870s. And Huygens spot was another spot in a similar part of Jupiter. So Jupiter goes through these long-term cycles of activity, and spots come and go all the time. Features come and go, and it's so fascinating that we can see all this with amateur telescopes. And you can see a little bit of irregularity there on the other main belt, the North Equatorial Belt. And with a suitable optical setup, you can magnify that and see finer details, see smaller spots. But you can see the seeing is a lot better in this part of the sky because Jupiter is so high. Jupiter is dominating the evening sky. Really, it's still high up between about 8 and 10 p.m. in the evening. And apart from Venus, which is in the twilight sky, Jupiter is the brightest object in the sky at the moment. Will continue to be visible for several months. But it's being joined by Mars. Mars is a bit further east. Mars is almost the same brightness as Jupiter, but Mars has a distinctive red color, so you cannot mistake the two. So let's leave Jupiter now. And what I'll do for Mars is I will simply show you the picture of Mars that I took last night. After I showed Mars on the National Astronomy Week broadcast, I took an image of it. And so I'll show you what Mars looked like last night, which is pretty much what Mars would look like now if we were looking at it. There it is. Because Mars rotates in almost exactly 24 hours. So in the period since last broadcast that we did, it's rotated round once. And we would see this view with the Solis Lacus, which is this circular patch in the southern hemisphere. This image has got south at the top. And we would see the North Polar Cap. We would see, this is the area of Olympus Mons volcano, but since it's fully illuminated, we can't see that at the moment. And we might see clouds as well. It looks as if there's a streak of cloud here. This is the Valles Marineris area, and it looks as though there's a streak of cloud or dust through that area. So although the atmosphere of Mars is very thin, we can see quite a few things happening. We see clouds, we see dust storms, and so forth. You probably won't see as much detail as this visually through a telescope. And this, as I say, is taken with a big telescope, a 14-inch telescope. But you, even with a smaller, say a telescope around 6-inch, that's 150 millimeter aperture, you will see the polar cap quite easily, and you will see some of the dark markings. But you do need a steady telescope, a higher magnification, probably 200 times at least, and good conditions. And it's a small object. It's a tiny object. If you compared it with one of those craters that we were looking on the moon, it would be smaller than one of those big craters in the telescope. So it's no wonder we cannot see that much detail on it. But it only comes round once every 2 years. It's just been through opposition. We won't see it as well for another 2 years. It's already on its way away from the Earth. It's about 50 million miles distant from us now, rapidly increasing. Its diameter is now 13 arc seconds, as it says on that picture. So it's it's changing actually by 1/10 of an arc second per day. So we've only got a couple of weeks to look at it now before it gets too small, really, to see any of the features. And that was taken with a Barlow lens as well. And a Barlow lens is a device that you add to a telescope to increase the magnification. Barlow lens is a very useful thing to have. So we've covered all the planets that are in the sky. Apart from Neptune, which had already set, we've covered Saturn, Venus, the Moon, Uranus, and Jupiter, and Mars. And that's the order that you see them in the sky, along that line of the ecliptic on which they are aligned, but not really aligned. But there's a great deal else in the sky. There are a lot of stars, obviously, and stars can change. They can change their brightness. They can explode from time to time, and some astronomers make a big study of stars that vary and stars that explode, stars that become novae or supernovae. And Martin Bracken is I think he's in Hampshire. I can't remember now.
I'm in Chelmsford.
Chelmsford, I was completely wrong there. Martin Bracken in Chelmsford, he's studied a supernova, and he's going to be able to tell us a little bit about that adventure.
Thank you, David. Let me just share my screen. Okay, if I just share that, show from current slide. Okay, so basically on the 16th of May 2023, I was imaging the Pinwheel galaxy M101, which is approximately 21 million light years from Earth. And the next morning when I got up, I noticed on Twitter that a Japanese astronomer called Koichi Itagaki had discovered a supernova in the M101 Pinwheel galaxy. That was on the 19th of May. And I'd been imaging this galaxy for a few days. So I looked back on my images from the 19th, the 18th to the 19th of May to see whether I had indeed captured the supernova. And so if you just look where that little arrow is, can you see the arrow?
You can.
You can, okay. If you look where the little arrow is, you will see that the difference between the two images, you see the supernova has appeared on the 19th of May. Well, that was amazing to me because as I say, this happened 21 million years ago, and I just happened to be imaging it at that exact point, which was marvelous. But it got better because over the next 7 days, I rarely get 7 clear nights in Chelmsford, but over the next 7 days, I managed to image the supernova every day. So I've seen its expansion over those 7 days. It was given a designation of SN 2023 IXF, and it was designated as a type 2 core collapse supernova, which means that it's expected to leave behind either a neutron star or a black hole, based on what we currently know about stellar evolution. So if you just look here, this is the 16th of May, where there was no supernova. This was the 19th of May, where you can see the supernova has appeared. On the 20th, it's got slightly larger. On the 21st, it's got even larger. The 22nd to the 23rd, it's got larger. 23rd to the 24th, it's got larger. And from the 24th to the 25th, it's got larger. And again to the 25th, 26th, it seems to have stalled. And basically, it started magnitude, its initial magnitude back on the 19th was a 14.9. It expanded to the magnitude went up to about 11, maxing out around about the 23rd, 24th. But it stayed visually it stayed in the sky, people able to look at it until about the 10th of June when it started to fade, 2023. So, you know, I feel absolutely privileged to have been able to image that for 7 days and capture the expansion of a supernova that happened 21 million years ago.
Well, that is great, Martin. Have you seen any other supernovae?
I haven't, no. The one previously, I understand, was about 9 years previously, 2014 in Messier 82. But
Yeah,
unfortunately, I wasn't imaging at that point, so I didn't manage to catch it.
Yeah, that was actually the one in Messier 82 was quite a famous one because it was discovered by students at the University College London Observatory in North London. They were just doing a student exercise and imaging a galaxy, and their supervisor, I think was called Steve Fossey, was on the ball enough to notice that there was something wrong in the image and realized that a supernova had appeared in this comparatively close galaxy. And I was able, it was a bright one. It was visible visually in large amateur telescopes, and I was able to image it from North London. So yes, we see supernovae in these distant galaxies. So this is the thing to explain, that supernovae can occur in the Milky Way galaxy as well, but they're quite rare. They're only every few hundred years, and the last bright one was the Kepler supernova back in the 17th century, the last really obvious one. There hasn't been a really obvious one recently, although there was one in the Magellanic Cloud back in the 1990s. But so generally, the supernovae that we see as astronomers are the ones in external galaxies, which are obviously a lot fainter and require telescopes to see. And it's a very important area of astrophysical study, because studying the way that the light increases and decays from the supernovae is important clues about stellar evolution and also the scale of the universe. We can use these explosions to measure the distances in the distant universe as well.
I think the thing that amazed me more than ever was the fact that I was able to image it as it actually happened, which is, I think, must be quite rare.
Yes, that is rare, and it's really valuable to have those images from which you can estimate the brightness at a very early stage, so we can see exactly what's going on when it first goes off. So yeah, well done with that, Martin.
Oh, thank you.
So I mentioned earlier on that we would be talking about Herschel objects, the deep sky objects discovered by Herschel. And this is a speciality that Trevor Pitt, who lives in Chichester, he's made a bit of a speciality of this. So now you've got a few minutes to you can talk about your observatory a bit. We've only got 10 minutes left, or you can talk about the Herschel objects, Trevor.
Okay, well, just very quickly about the observatory, I suppose, where I am and what I do there. So my location, although it's Chichester, I'm actually a little bit further south than that. I'm one of the people that decide on their house based on the observing conditions, and I had to sort of commit myself to being really close to the sea as possible. So there is a picture of my observatory, and just over here you can see a little gap between the houses, which is about an hour and a half of sidereal time, down to about 5 degrees above the horizon, so I can get really quite low from the observatory. And there's a picture from the observatory, which of course is
We can't actually see any pictures, Steve.
you can't see them.
Rather, we can't actually see the pictures.
Hang on a second. Am I not sharing? I thought I was sharing. Is that better?
Yeah, it's coming. Yeah.
I didn't click it hard enough. Sorry about that. There we go. Just go back a couple. So I'm based between Bognor Regis and Pagham down on the south coast, and I'm pretty close to the sea. The sea is just here in this field of view. I did ask this person here to knock his roof off, but he refused. But so I'm limited to about 5 degrees above the horizon from the observatory. And that's the view that I get through Stellarium, which you can put a picture in Stellarium to represent your view. So it does go down pretty low, as you can see. In terms of telescopes, in the observatory, I use 2 or 3 main ones. But the Meade 250, that's an f10, 2,500 millimeters focal length, which of course, as you've been talking about tonight, we can also add on a ×2 Barlow on that to get to 5 meters. So that's quite a long focal length, good enough for planets and for detailed views of the moon as well. And I do quite a lot of work on the moon. Other telescope I use is the RC200, Rishi Sharetian 200. That's about 1.6 meters focal length, and with the camera, which you can see in the bottom left-hand corner here, that's a 26C APS-C size sensor on it, which with a 1.6 meter focal length actually just fits the moon, unless it's a supermoon, onto the field of view. And as you were talking about earlier, you can zoom into 100% and just move the field of view of the camera around without having to move the moon around. Now, I'm mainly a visual observer from the old days, probably, and this is my 20-inch telescope, which I use and have been using for some time now. And you can see that you do need to go up a ladder to actually visualize through it. But it's the same focal length as the Meade telescope I just showed earlier, and it's very interesting to compare the two. I often have myself observing with the big Obsession 20-inch, and also imaging with the Meade telescope on the same part of the moon or an object, and just comparing the two views. Through visualization, you do see a lot more detail than you do through a camera, but you don't see as good detail as when you stack the camera images together and produce a nice view from there. So that is a quite interest. The whole point about what we were talking about, the Herschel 400, of the 2,500 objects that William and Caroline observed, they produced their own catalogue, from which 400 have been chosen into another catalogue called the Herschel 400. And you can see there a book by Stephen O'Meara, who is a pretty good observer himself, visual observer. But out of those 400 objects, there's 231 galaxies, 107 open clusters, 33 global clusters, 20 planetary nebula, and 7 bright nebula. There are some overlaps between what we call the Messier catalogue of deep sky objects. There's 17 objects in the 400 are from the Messier catalogue. And even from Patrick Moore's Caldwell catalogue, which he produced, there are 44 objects which are swaps, if you like, between the two. And observing them, I started in 2013 with a very small telescope, only a 5-incher, and I couldn't see everything. So the skies in the UK, as you know, are not always good, and I had to go bigger and bigger in size until I ended up with the 20-inch to see them. And you can see here that I keep all the observations in a catalogue, and this is a Deep Sky Planner software, which is where I keep all the observations. And at the same time, in the observatory, I'm taking pictures of the objects. So I've got a complete catalogue of visual observations and comments about the visual observations, and compare that with the pictures that I take as well. So that's how I do the visual and also imaging as well.
That's great, Trevor. It's nice to have some visual observing and some hints and tips on how to do it and objects of interest. And it's good to see a coordinated, an attempt to do a comprehensive project, looking at a whole set of objects. So we have another team who've been waiting very patiently. This is the Hampshire Astronomical Group, who last time I communicated with them were completely clouded out, like I am. But let's go over to Hampshire and Steve Futcher and see what it's like there. What's it like in southern Hampshire, Steve?
Still clouded out, unfortunately.
Would you like to show us some observations you'd taken earlier?
Yeah, just trying. Okay, so hopefully you should be able to see, this is Venus. This is actually the shot I took about 2 days ago. This is a 3-minute video stacked in auto stacker. This was taken on our 16-inch astrograph.
The big telescope. That's the size telescope, is it?
Still trying to learn how to use it. This is a picture of Mars I took 2nd of January on my 8-inch Celestron. Little bit fuzzy, unfortunately.
You've got quite good detail there, yes.
Yeah, I was hoping for better, but I couldn't pull out much more with wavelets. This is it's going to play. No. This was actually a time lapse, which doesn't seem to be working, of Jupiter back in 2015. But you could actually see the moons rotating round Jupiter and Jupiter itself moving. And you've got the red spot there. This is Jupiter I took at the beginning of January, and I think that's Io and that's Ganymede.
Those moons look beautiful there. You can really see that they're little disks, they're little worlds.
Yeah, that's right.
Very nice.
This is going back to 2014. We're talking about M82. This is the supernova in M82 that we captured on our old 16-inch. This is the one that was discovered by Steve Fossey and his students that you were talking about earlier.
Yeah, that's lovely. Yes.
Now, occasionally you take a picture of a galaxy before the supernova, and as luck would have it, I already had a picture of the fireworks galaxy that I took in November 2016 on our 24-inch here. And this is an image I took in May 17, and you can see here that the supernova is suddenly appearing. And that's not done with Photoshop, that's real supernova.
Yeah, that's well done.
Now this is M101, and again, similar thing, I managed to have an image taken of it before and with the supernova. I think this was taken with one of the telescopes at iTelescope in the States. And finally, I think right at the beginning in the introductory talk, we're talking about Polaris, and you can actually just put a camera and point it at Polaris and take lots of 20-second exposure or 25-second exposures, and you can stack them in something called Star Trails XE. So quite a good little exercise if someone at home wants to try that. All you need is a camera and a tripod and a computer to process it.
Yeah, a very visual demonstration of the rotation of the Earth and the rotation of the stars around the North Pole of the sky, the easiest type of astrophotography to do, to
Yeah.
take star trails.
Yeah, and you also pick up the different colours of the stars, which is quite nice.
You do. They're blue and they're orange and reddish, all colors, depending on their different temperatures. Well, I hear. Thank you very much. That's maybe we'll actually get some images later in the week from the Hampshire Astronomical Group. But I've been told that the indefatigable Grant Bowskill has managed to turn the telescope in Spain onto Mars. So let's go over to that if you've got that, Grant. Just right at the end of this broadcast.
There we go.
There it
So
is.
it's small, but you can see a bit of detail there. You can see a bit of ice cap on the bottom there. And the longer you look at it, you'll see moments of clearer seeing where you see a little bit more detail. But yeah, as you said earlier, it's very, very small in comparison to some of the other objects we've looked at. So I've blown it up as much as I can.
And that reminds me that you should always take your time observing. You don't see much when you first try, but the more you look, the more you see. So persistence is really key in visual astronomy or any astronomy, particularly in a place like England where we've got so many clouds. But fortunately, we've got the telescope in Spain, and fortunately, some places in the west of England were clear as well. So we've been able to get quite a lot of live views tonight to add to the collection of live views we've had over the course of this week. And we'll be here tomorrow with a different presenter, and same format really, at 7 p.m. to 8 p.m. So hope you've enjoyed it. It's been quite a fun thing to have this tour around the sky, and we'll see you again tomorrow, hopefully. Good observing, clear skies, night night.